Everyone, notes 5.7 are on solving quadratic trigonometric equations. So the first question that we have here says to solve sine squared x minus sine x equals 2 over this interval right here. Again, this should be x and not theta. And then we'll verify the solutions using graphing technology. So the first thing I want to do is I want you guys to notice that it might be easier to let u equal sine of x, because if I let u as sine of x, then this just turns into u squared minus u equals 2. And that's nice and easy to solve because it's a quadratic. Get everything on one side, and then all I need to do is factor. So I get u minus 2 times u plus 1 equals 0. So that means that u equals 2 or u equals negative 1. But since u is equal to sine of x here, I'm going to replace u with sine of x, and I'm going to say sine of x equals 2, and then I'm going to say sine of x equals negative 1. Now, if you guys remember, sine of x without any transformations, the smallest value that sine of x can be is 0. Well, I guess technically negative 1, and the largest it can be is positive 1, but it can't be anything more than 1. So therefore, this right here gives us an inadmissible solution. So this right here is an extraneous solution. So then our other possible answer happens when x is equal to, now if I'm going to look for where sine is negative 1, I know it's negative 1 down here, which is 3 pi over 2. So x equals 3 pi over 2, and that's my solution to question number 1. Okay? So now if I want to verify the solutions using graphing technology, what I'm going to do is I'm going to graph out y equals sine squared x minus sine of x right here, but I want it to only be from 0 to 2 pi, and make sure that you put these in our bracket notation right here. And then I'm also going to write y equals 2 for my other equation, and I'm going to see where they intersect, and they intersect at the x value of 3 pi over 2, which is why 3 pi over 2 is our solution right here. Okay, so now let's take a look at question number 2. Number 2 says 2 cosine squared x minus 3 cosine x plus 1 equals 0. So this time what I'm going to do is I'm going to let u equal cosine x. Okay, so when I do this, this turns out to be 2u squared minus 3u plus 1 equals 0. So when I factor this right here, I'm going to use 2u and 1u, and this here I can only use 1 and 1, and this gives me 1u, and this here gives me 2u, and that gives me the 3u that I want if they are both negative. Okay, so I'm not teaching how to factor. I'm just talking about how we can use the factoring to figure this out. So this here, right here, means that u is 1/2, and here this means that u is 1. But because u is cosine of x, we're going to say cosine of x equals 1/2. And we're going to also say that cosine of x equals 1. So we'll take a look at our unit circle, and we're going to see, well, where is cosine equal to 1/2? Well, we know cosine is positive in the first and the fourth quadrants, and we know that cosine is the x value, so we know at 1/2 root 3 over 2 this works, and this works at pi over 3. So this means that x could equal pi over 3. But we have the exact same triangle in quadrant 4 with the related acute angle of pi over 3. So right here, the angle that works is 2 pi minus pi over 3, which is 5 pi over 3. So that's another answer that works. Okay, and then we also want to look for where cosine is 1. Well, we know cosine is 1 at 0. And then when we make one full revolution around, since x has to be between 0 and 2 pi, we'll also say that 2 pi works. So that means that x could also equal 0 or 2 pi. So therefore, my solution set, and I'm just going to put it in from smallest to largest, is going to be 0, pi over 3, 5 pi over 3, and 2 pi. Okay? All right, so for number 3, it asks us to solve for 3 sine x plus 3 cosine 2x equals 2, where 0 is between x and 2 pi. So what I'm going to do is I'm going to take a look and see I've got sine x and I've got cosine of 2x, and I need everything as much as possible to be the same trigonometric ratio. So I know that cosine of 2x is equal to cosine squared x minus sine squared x. Okay. I also know that cosine of 2x is equal to 1 minus 2 sine squared x. And I also know that cosine of 2x is equal to 2 cosine squared x minus 1. Okay. So taking a look at this right here, I probably want to use this one right here to plug in for cosine of 2x, because then I will now have an equation with all just signs in it. Okay, so then I'm going to distribute this 3 through right here. So I get plus 3 minus 6 sine squared x equals 2. And then I'm going to get everything on one side. Now, let's let u equal sine of x here. Okay, so I'm going to say 3u plus 3 minus 6u squared equals 2. So if I get everything on one side right here, this negative 6u squared becomes positive 6u squared. I would subtract 3u, and then I would subtract the 3 here, so I would get minus 1. And looking at this right here, I can see this is not factorable. So I'm going to use the quadratic formula to solve for u. So I'm going to say negative b, which is positive 3, plus or minus the square root of negative b squared. Please do not forget to put that negative 3 in brackets, minus 4 times a times c, all over 2 times a. Okay, so I end up getting u equals 3 plus or minus the square root of negative 3 squared is 9, and then negative 4 times 6 times negative 1 is positive 24, all over 12. So I get u equals 3 plus or minus the square root of 33, excuse me, I don't know where I got that 25 from, all over 12. So then that means that I will end up getting 2 answers. U is either equal to, so let's go ahead and type this in right here, 3 plus 33 square rooted, enter, and then divide that by 12. And I end up getting 0.7287, so u is equal to 0.7287, or u is equal to approximately, right here, let's do the same thing, 3 minus the square root of 33, and then divide that by 12, and I end up getting negative 0.2287. So now that I've done that, and I know that u is sine of x, then this means that sine of x is either equal to approximately 0.7287, sorry, that should say a 7 there, or sine of x is equal to approximately negative 0.2287, okay? So in order to solve for x, I have to take the inverse sine of these values right here. So inverse sine of 0.7287, or the inverse sine of negative 0.2287, okay? So now what I'm going to do is I'm going to take the inverse sine of 0.7287. Make sure that you are in radians in order for this to work for you. And when I do that, I get 0.816. So right here, x is equal to approximately 0.816. But we have to use the cast rule. So if we look and see, where is sine positive? It's positive in the first quadrant, and it's positive in the second quadrant. So here we know that our related acute angle is 0.816. So in the second quadrant, our related acute angle is 0.816. So our other value of x has to be pi minus 0.816. So when I do that, if I take pi and I subtract 0.816, I end up getting 2.33 approximately. So x is approximately equal to 2.33. Okay, so those are our 2 answers so far. Now for our second answer here, what I'm going to do is I'm going to find the inverse sine of positive 0.2287 to find the related acute angle. Okay, so when I do that right here, I'm going to take 0.2287, take the inverse sine of that answer, and I get x is approximately equal to 0.23. Sorry. 0.231. Okay, so I'm going to look at this as well. This time sign is negative, so it needs to be in the third and the fourth quadrants. So my related acute angle is 0.231 in both quadrants. So to find the actual values of x right here, so let's just use a different variable here so we don't get them confused. So I'll use a for relate acute angle. So x is going to equal pi plus 0.231, and x is going to equal 2 pi minus 0.231. So we'll type those in and see what we get as our answers. So here we'll get pi plus 0.231 here, and we end up getting 3.373. And then here, when I plug this in, 2 times pi minus 0.231, I end up getting 6.052. Okay, and let's go back to the one that we have in purple here, because I want to be consistent. If I'm going out to 3 decimal places for all the other ones, I want to do the same thing with this. So pi minus 0.816 would be 2.326. So let's fix this to 2.326 so we are consistent. And that makes our solution set equal to 0.816, 2.326, 3.373, and 6.052. Okay, we'll just verify this graphically and then we'll be done. I'm going to type into decimals y equals 3 sine x plus 3 cosine 2x, and then I'm going to type in y equals 2 for over the interval 0 to 2 pi. And if you notice, the blue graph is the left side of my equation, the orange graph is the right side of my equation. So looking to see where they intersect right here, we get all the same answers. This is off by 100th, and this is also off by 100th, I believe. That's just because we did some rounding up here. If we hadn't done any rounding and we actually took the inverse sine of this radical over here, we would get a more accurate answer. But being off by 1,000th isn't that big of a deal. And that's it for this. All right, so let's take a look at number 4 now. And in number 4, it says secant of x times cosecant of x is equal to 2 cosecant of x. On this interval, again, please make this an x for me. Sorry about that. So right here, we're going to change everything into sine and cosine, okay? So right here, secant of x I know is 1 over cosine of x, and cosecant of x is 1 over sine of x, and 2 cosecant of x is 2 over sine of x. Now I'm going to find out what my restrictions are. So my restrictions will happen when my denominators are equal to 0. So cosine of x cannot be 0, and sine of x cannot be 0. Okay, so that means that x is not allowed to be, now if I look at my unit circle, cosine of x is 0 at pi over 2 and at 3 pi over 2. Okay, sine of x is not allowed to be 0, and we know sine of x is 0, at pi, and then again at 2 pi. So x is not allowed to be 0, pi, or 2 pi. Now here we would normally say x is not allowed to be pi over 2n, but because we've got a specific interval, these are the only 5 values where x is not allowed to work here. Okay, so now let's go back to solving this. So I'm going to put this together into one fraction right here. So I'm going to say 1 over cosine x sine x is going to be equal to 2 over sine x. Now I have a rational equation, so I'm going to find my LCD, which is cosine x sine x, and I'm going to multiply both sides by my LCD. Okay, so I'm going to multiply both sides by cosine x sine x, You know what? I'll write it out twice. And when I do that, I can see this cosine x, sine x will cancel out with this, so I get 1. And I can see these sine x's cancel out, so I get 2 cosine x, which turns out to be pretty nice for us. So divide both sides by 2, I get 1/2 is equal to cosine x, which means that x is equal to, let's see, what values of x, or what values of theta will give us 1/2. So when I take a look at this right here, just like we did before, we figured out that it's at pi over 6 because our coordinate is 1/2. Root 3 over 2. So pi over 6 is one possible answer, but the cast rule tells us that it's also positive in the fourth quadrant, and we know our related acute angle is pi over 6 right here, so our answer is going to be 2 pi minus pi over 6 again, which is 5 pi over 6. So 5 pi over 6 is my other answer right here, so that is my solution set. Okay, but I would like to graph this out to see what this is going to end up looking like. So let's go ahead and do that right now and see what we end up getting. So I'm going to go to Desmos and I'm going to type in y equals secant of x times, for some reason Desmos needs me to write this in brackets, times cosecant of x, but again from 0 to 2 pi. Okay, so this is my first graph, and I'll move it over so you can see it in a second. And then my second graph is going to be 2 cosecant of x, and same thing, this needs to be from 0 to 2 pi. So when I take a look at what I have here, I can see where they intersect with each other, and they intersect with each other at pi over 3 and again at 5 pi over 3. So our solutions to this equation, sorry about that, our solutions to this equation are correct. Okay? All right, that's it. Let me know if you have any questions, and I will see you later. Bye.